of those days you're so busy, you don't have the time to eat? Do you ever find yourself in a situation where you have to get some quick energy? Would you rather grab a banana or eat a dextro? Well, today we're at Maastricht University and we've arranged an interview with nutritional expert Evie Verweg, who's going to give you all the answers. So, Evie, you're going to perform an experiment today. Can you tell us more about what is going to happen?
Well, we want to find out which type of sugar has a quicker bioavailability. We are testing two types of sugar, either fructose powder and glucose powder. Essentially, we are comparing digestion of two monosaccharides, and we are testing this with an experiment where one participant will be ingesting the fructose powder and the other participant will be ingesting the glucose powder.
Well, that sounds interesting. What exactly is the connection with dextro and bananas?
Let me tell you something about that. Bananas exist mostly out of fructose and dextro tablets exist out of glucose. So with this test you can measure which one has the quickest bioavailability, a dextro tablet or a banana.
Okay, but what exactly is being measured there?
The calorimeter gives us values of oxygen, carbon dioxide and the respiratory quotient. With these values we can measure the fat oxidation and the carbohydrate oxidation.
Okay, that's interesting. But how is such an experiment exactly carried out?
Well, we chose two participants with a similar height and body posture, and we did this to avoid subject bias. The participants both fasted for 12 hours so that we can see the clear effect of the glucose and fructose powder. They are randomly assigned to either consume the glucose or fructose powder, which is diluted in water. 75 grams of either fructose or glucose powder will be mixed with approximately 150 milliliters of water. And then the participants will take place on the beds and they will put on the ventilated hood and they will rest for 30 minutes. And during minute 1 to 30 we'll write down the values of the oxygen, the carbon dioxide and the RQ every minute.
159.87, 0.80, 262.73, 194.91, 0.76.
And after 30 minutes, the participants will consume the fructose or glucose powder, and then they will be resting on the beds for another 46 minutes. And after 10 minutes, we will continue to write down the values every minute.
Wow, that all sounds very interesting, Evie. Well, I wish you a lot of luck and I hope to see you again.
For pre-measurements, both participants use more oxygen than carbon dioxide. Participant 1 uses less oxygen and less carbon dioxide than participant 2. For pre-measurements, both participants use mostly fat, then carbohydrates, and less protein. The protein use between participants is merely the same. Participant 1 uses more carbohydrates than participant 2, and participant 1 uses less fats than participant 2. For post-measurements, the respiratory exchange rate increases over time for both participants. The average respiratory exchange rate for participant 1 is higher, mainly because of the higher pre-measurement respiratory exchange rate. For post-measurements, the respiratory exchange rate increases over time for both participants. The average respiratory exchange rate for participant 1 is higher, mainly because of the higher pre-measurement respiratory exchange rate. For post-measurements, participant 1 who drank the glucose drink uses more carbohydrates and less fats. The use of carbohydrates increases a lot, while the use of fats decreases, but not as much. The usage of proteins doesn't differ over time. Post-measurements for participant 2, who drank the fructose drink, uses more carbohydrates and less fats. The usage of carbohydrates increases a lot, while the usage of fat decreases, but not as much. The usage of proteins doesn't differ over time. Coming to a conclusion, after 12 hours of fasting, both participants use mostly fat in their oxidation. Also, after 12 hours of fasting and drinking either glucose or fructose, both participants start to oxidize more carbohydrates and less fats. Drinking a glucose drink after 12 hours of fasting leads to smaller increases of carbohydrate oxidation compared to the increase of carbohydrate oxidation when drinking a fructose drink. Therefore, the participant that consumed the fructose had a quicker uptake compared to glucose. So, according to this research, you can conclude that a banana leads to quicker energy uptake than a dextro.
Next time when you need some quick energy, grab a banana.
There are some limitations to this experiment. You are never totally fasted when you would consume a quick sugar. Additionally, bananas contain more nutrients than only fructose, but these were not taken into consideration. Also, individual metabolic rate differs, and this was not a crossover study, therefore this was not taken into account. And lastly, the research population was too small to come to a valid conclusion.